something doesn't add up. Could it be that the universe is far older than we imagined? Or that the Big Bang Theory, the cornerstone of modern cosmology, is missing a critical piece of the puzzle? This is more than a scientific head-scratcher. It's a full-blown astronomical identity crisis. The James Webb Telescope, hailed as one of the greatest feats in engineering history, is not just showing us the past, it's rewriting it. This $10 billion observatory is so powerful it could detect the heat of a bumblebee on the moon from Earth. With its 6.5-meter mirror and precision infrared instruments, it's revealing the secrets of the Dark Age, the era just after the Big Bang, and uncovering cosmic structures that challenge everything. As Webb peers deeper into space and further back in time, it's becoming clear the universe may be far stranger and older than we ever dreamed. We've uncovered something that defies everything we thought we knew. Even the most brilliant minds in history, like Albert Einstein, weren't immune to getting it wrong. At one point, Einstein was so convinced the universe was static and unchanging that he introduced the now famous cosmological constant into his equations to keep it that way. But when it became clear the universe was actually expanding, he removed it, later calling it the biggest mistake of his career. Ironically, that same constant will be brought back decades later to explain the universe's accelerated expansion. Despite all the scientific U-turns over the years, there's still one idea most scientists hold dear: that the universe began 13.8 billion years ago with the Big Bang. But don't think of it like an explosion in space. The Big Bang wasn't an outward blast into a pre-existing void. It was the sudden expansion of space itself, where time, matter, and everything else emerged from an unimaginably dense, hot singularity. So how can we be so sure about a moment we never saw? The key lies in reversing the universe's expansion. By tracing it backward, physicists land on a point where everything compresses into infinite density and zero volume. The singularity that started it all, but the real smoking gun, the cosmic microwave background radiation. This faint glow from the early universe is spread almost perfectly across the sky, a remnant heat signature from a time just after the Big Bang. It's one of the strongest pieces of evidence we have for the universe's explosive beginning. And based on this model, the first galaxies that appeared should have been small, still taking shape in the young cosmos. But what we're finding out now, especially thanks to the James Webb Telescope, is challenging that belief in ways no one expected. Astronomers once believed the first stars appeared roughly 200 to 300 million years after the universe was born. But how these stars came together to form galaxies and how fast they evolved has remained one of the cosmos's most elusive mysteries. Recent observations from the James Webb Space Telescope, however, have thrown a cosmic wrench into everything we thought we understood. Initially, Webb's images aligned with expectations. Faint, small galaxies, just 300 million years post-Big Bang, low in mass and still in their galactic infancy. But then came the shocker: 6 galaxies from the same era that were not only fully formed, but already rivaled the mass of our Milky Way. That's not just unexpected. That's a direct challenge to the foundational assumptions of modern cosmology. Astrophysicist Webb, part of the team that analyzed these Webb images, described the moment with disbelief. I ran the analysis software, and it spat out two numbers. Distance, 13.1 billion light-years. Mass, 100 billion stars. I almost spit out my coffee. These galaxies, born impossibly early and with impossible mass, simply shouldn't exist. Not according to our current models. Web's team, based at Swinburne University of Technology in Melbourne, focused on deep-field images taken near the Big Dipper, a slice of sky previously studied by the Hubble Space Telescope. But Webb's near-infrared NIR cam revealed something far more intense, reddish glimmers of light that hinted at unimaginable distances. By calculating redshift, scientists determined the light from these galaxies had traveled for more than 13 billion years. In other words, we're seeing ancient giants that existed just 500 to 700 million years after time began. These galaxies should have been tiny, cosmic toddlers just learning to form stars. Instead, they were massive, mature, and bursting with stellar activity. Their very existence challenges the timeline of how structure formed in the early universe, and may mean we've been reading the wrong chapter of the cosmic story all along. The data from the James Webb Space Telescope was nothing short of jaw-dropping. All 6 of the ancient galaxies it detected carried more than 10 billion solar masses of stars, and one of them might even be pushing the 100 billion mark. That's the kind of mass we typically associate with mature galaxies like the Milky Way, not cosmic infants that emerged just a few hundred million years after the Big Bang. So how could these monstrous galaxies form so early in the universe's timeline? According to our current understanding, there simply wasn't enough normal matter back then to make this possible. To account for it, either the density of matter in the young universe was 2 to 5 times greater than predicted, or something far stranger is at play. A completely new process of galaxy formation we've never even imagined. And that's where the real dilemma begins. Either explanation demands a fundamental rewrite of our cosmic playbook. Enter Rajendra Gupta, an astrophysicist from the University of Ottawa. His team made a bold claim that could shake the foundations of modern cosmology. The universe might be twice as old as we thought. According to Gupta, the strange discoveries Webb is making aren't outliers. They're clues pointing to a much deeper truth, and the evidence just keeps piling up. Since the original 6 galaxies, Webb has uncovered even more puzzling objects, like the recently announced Big Wheel galaxy. This beast has a mass nearly 5 times that of the Milky Way, and appears so ancient that its existence directly contradicts everything we thought we knew about early cosmic structure. Then there's the Methuselah star HD 140283, lurking in the constellation Libra. It's estimated to be between 13.66 and 15.36 billion years old. That would make it older than the universe itself, which we believe is 13.8 billion years old. Think about that. A star older than space-time as we know it. If even one of these objects truly predates the age of the universe, the Big Bang theory, or at least how we interpret it, could be fundamentally flawed. What if the universe didn't begin the way we thought? What if we've only scratch the surface of a far deeper, older and more complex cosmic history. Well, you might think we've uncovered a cosmic contradiction, but not so fast. The key issue here is measurement uncertainty. Scientists warn that there's always around a 30% margin of error in age estimations like these. That means most estimates for the Methuselah star's age still fall within the accepted year range, though some don't. And more recent analyses even suggest it could be much younger than originally thought. Still, astrophysicist Rajendra Gupta and his team from the University of Ottawa aren't buying the old timeline. Their controversial conclusion: the universe didn't begin 13.8 billion years ago. It began 26.7 billion years ago. Their argument zeroes in on redshift, the very method we use to calculate the universe's age. According to Gupta, this model overlooks crucial variables known as coupling constants, which define how particles interact. If these constants have changed over time, and the models allow for that, then the formation of early galaxies seen by the James Webb Telescope could have taken billions of years, not just a few hundred million. That twist gives those massive early galaxies plenty of time to evolve, solving one of the biggest cosmic puzzles uncovered by Webb. But Gupta didn't stop there. He also calls for a radical rethink of dark energy, long believed to be a mysterious force accelerating the expansion of the universe. And here's the kicker. Other recent studies now suggest dark energy may not be constant after all. It could be weakening. That insight only deepens the cracks in our current understanding